Do it again.
All right, so, so, so I have the battery attached, okay, and this is my little cheesy thrown together, perf board and a switch here that turns the power on to the whole system. The controller board is mounted underneath the top plate. Puts it closer to the top here. Later on, I want to get some servo mounts and some servos, and I want to mount some sensors up here, like one or two ultrasound sensors that are going to spin around on the top and shoot out sound waves so it can kind of see the stuff around it and avoid hitting things. All the motors are hooked up, power blocks hooked up, and it's on the battery. So I'm gonna turn it upside down, and all the motors are powered up. It's gonna get itself going here, and I'll just start driving the wheels. So they're all driving in the same direction. This is at 20% duty cycle on 12 volts, so not bad. So the tires right now don't have, they're just plastic tires that are kind of smooth. They don't have a lot of traction. Yeah, still got the tape on there to make sure so I could figure out what direction they were going. Really hard to see what direction a solid black smooth wheel is going by itself. Kind of helps to have tape. So I got it on the rubber mat here protecting my workbench, and it should move towards me, I think. Moves pretty fast. Gets a good grip going. So now that I've got that worked out, I'll work on the library that drives the motors and give it some better control, like turn left, turn right, spin left, backwards, forwards, stop. So it's usable. Kind of build a module above it. Might actually also fire up the UART here and use that to output data while it's running. Like maybe I could read a 19:1 gear ratio, so factor that in plus the pulse width mod and the quadrature encoder count. Should be able to tell what speed the motors are going, probably by RPM, how many RPMs and stuff. That'd probably be useful to be able to pull out of the thing. But yeah, not bad for, couple hours on a weekend building up a mechanical body to hold everything. Another hour to build some distribution circuits and test them out, make sure they're okay. And the power's clean enough to drive the motors. And I spent, I don't even know what time it is. We're filming this at almost 11. So I've spent probably about 2.5 hours troubleshooting the demo code that Digilent put out as a demo H-Bridge driver library for driving the motors. And it turned out that they had one of the pins off. So the pins are labeled on the ports on the board here, and they're dual layer ports, right? Because there's a lot of pins on this PIC 32, so they break as many as they can out all over the place, so you have a lot of peripherals you can use and a lot of peripheral modules that you can connect to this board, such as H-Bridge drivers or all kinds of peripheral mods that they sell. I'm not really familiar with all the stuff that they have. They have a lot of stuff available to work with these ChipKit Pro boards and their FPGA series of boards, like the Zybo board or the Z board, is it Nexus boards and stuff like that. So They put out a lot of demo code. They have HBridge drivers in VHDL, Verilog, and C, and they also have an MPID for this as well. In another video, I'll actually regress the changes I made to the library and show you how I troubleshot and figured out what was going on by using the oscilloscope to look at the waveforms that were coming out of the board, and explain how I knew to look for that and see what was going on. So I'll do that in another video, but it's definitely not tonight. So, yep. It's working. At least for now. So until the next video.